Let's take a look at Euler's method, which he developed to approximate first-order initial value problems. And essentially, if you have an initial value problem, such as this, what he's just doing is using a starting spot and what he called time step. One can move through the slope field to show an approximate solution or an approximate path. And of course, he used an iterative approach. So your yk will be your previous values, yk, plus h times the function with t evaluated at the previous point and y evaluated at the previous point. Essentially, all this is saying is you start off with somewhere on your graph with an initial point and figure out what the slope is there from this initial point. And so maybe the slope is like this, and you move a certain amount. You move this certain amount called a time stop or time step. And then you get to a new point, and then you calculate what the slope is there, and you follow it until you get to that next time stop, and you calculate the slope there, and then you calculate the slope there. You just keep doing that with these time stops being like regular intervals, and you're just continuously using this iterative approach to estimate where this solution might be. So let's take a look with the example I gave of y dot equals y minus t squared and the initial condition. And we'll use these little time steps of 0.2. And you'll notice that we're using h to represent these time steps. So we have our first point, which is y of 0 equals 3. That's given to us as our initial condition. And now we start the iterative approach. So to find the next y value, we take the original y value. So I'm using the equation at the top. And then we add in the time step times the function getting evaluated at the previous. So this becomes 3 plus 0.2. And then I use this, so I get 3 minus 0 squared, and I now get a value of 3. And so we can find that location, and then I can go on to my next point, which I will use the previous point of 3.6, same time step, and now I use 3.6 minus, and now the time steps start. You can just continue this iterative approach to find the next locations of this slope field.